Okay, guys, so writing polynomials with imaginary and complex roots. You should have watched the video on imaginary numbers, so I numbers. Again, I'm going to start this like I did last week with, obviously, you factor equations, and you can have, these would be our factors of this polynomial, and we want to know what the zeros are. So we take each one of these, so x plus 2, set it equal to 0, and that one you've done a lot of. X squared minus 3, set it equal to 0. X squared minus 1, set it equal to 0. So obviously this is going to give us an x equals negative 2. We're going to have x squared equals a positive 3, and then take the square root of both sides because that's how you get rid of the x squared. So x equals the plus and minus, because there's always two answers when you square root anything, of 3. And I'm going to leave it this way because this way is the way you're going to see it more times than not than the nasty decimal that's going to give you. So we're going to add 1 to both sides. So x squared equals 1. Take the square root. X equals positive and negative 1. So positive and negative 1, because every time you take a square root, you get 3 solutions. So to the polynomial that has these factors, these would be your zeros, x-intercepts, or roots. So again, if I do x squared minus 2, and by all means, if you want to pause your video and try these real quick and try to solve for just the zeros, so maybe it helps you understand why we're working backwards. So add 2, take the square root to get rid of the squared. So x is equal to the plus and minus of the square root of 2, or whatever decimal that might be. Subtract 3 from both sides. So x is equal to a negative 3. X squared equals 4. Square root of x to get rid of that square, because again, that's what makes that square goes away. So x equals plus and minus 2. So it's plus and minus 2, or you could write x equals positive 2 and x equals negative 2. So this means it's going to be a 1, 2, 3, 4, 5 degree polynomial. This one would be a 1, 2, 3, 4, 5 degree polynomial as well. And remember, that's the leading coefficient, the highest degree of the polynomial. So every time you have anything that has the square root, there's going to be 2 roots. Square root, 2 roots, whether it's a nasty number or a nice even number, because 1 times 1 is 1, but the square root of 3 is not a number you will know. So again, that is just your brief beginning review. So if we are looking at these guys, so looking at your zeros going to your factors to be able to write the polynomial. So these, just like we said over there, the plus minus square root of 3 on our earlier example, this is plus minus square root of 6. So it can be written this way or this way. And that's again because every time you square root a number, it has 2 answers, the positive and the negative. So we're going to take these just like we did last week with our regular, nice, neat numbers, and we're going to set them equal to x and then get them by themselves. So 1/4 equal to x. And you could do square root of 6 equal to x. And you could do negative square root of 6 equal to x if you want to, but it takes care of itself once you square it. But for the conversations, we'll do both since it's there. So this one, we're going to multiply by 4. Then we're going to move the 1. So 0 equals 4x minus 1. So that's one of our factors. So we don't have a factor from this root or 0. I need to get the square root off of this. So we're going to square this side and square this side. So again, that just takes the root away. So 6 equals x squared. We need it equal to 0. So I'm going to move that 6 by subtracting 6 from both sides. So I have x squared minus 6. Do the same thing here. If I square this and I square this to get rid of the root, it's also going to get rid of that 1. That's a negative 1 in the front, which makes it a positive 1. So you still end up with that 6 equals x squared minus 6 from both sides, x squared minus 6. So these are the same. You don't need to use them twice. So again, you don't really have to do this twice. But what you do want to understand is no matter how it's written, if it's written this way, you see it's a 1, 2, 3. It's going to be a cubic polynomial or to the 3rd power. If you see it written this way, just know it's 1, 2, 3 as well. So now to take these two solutions, these two factors from our solutions and write the polynomial, we're going to multiply 4x minus 1 times x squared minus 6. And you're going to multiply those together. You can use FOIL, you can use box method, you can use whatever works for you. So